Hi everybody, welcome to Live Wire Review. I'm doing a special episode today on EV maintenance. Specifically, we're talking about batteries. I want to show you what's going to happen at the end of life of your vehicle's battery, or if you have a problem and you happen to need a rebuild. Well, let's get into it. Okay, I'd just like to start off right now with this hybrid battery. This was pulled out of a vehicle because it had two defective cells in it. Now there are several cells inside a battery, and when one of them doesn't work, it causes the whole thing to malfunction. In the case of this battery, one cell showed the proper voltage, but when you went to pull amperage out of it, it dropped very quickly, so the computer set a fault, and we had to take it out of the car. Keep in mind this is a very rare occurrence, but at least it gave us an opportunity to pull apart a battery and see what's inside. So this is a live battery, so first thing we're going to do is we're actually going to get our high voltage gloves on, and we're going to check and see what kind of voltage we have to work with. Now, high voltage gloves have to be recertified every 6 months. And before you use these gloves, you actually have to check for leaks. So what we do is we take them and we put them inside out and we roll them up in order to create an air bubble so that we can see if there are any leaks. So what you do is you just roll it up here until all the fingers come out, and that proves that there are no leaks in here. We take it and we put it back the original way. And we just do it again this way to get the gloves back in the right direction. And that one's stubborn. There we go. So this glove passes the test, and now we have to check the second one. Turn it inside out. And we just roll it up and make the fingers pop out again. So this test has to be done every single time you work with a high voltage component, because even a pinhole leak in these gloves will cause electricity to flow through them. And that's part of the reason why they get recertified every 6 months, is just to make sure that there are no pinhole leaks. They're also made out of natural rubber, and the problem with natural rubber is it does degrade over time, so that's another reason why we have to get these things certified. But it makes an excellent electrical barrier to keep us safe. Now, because they are natural rubber, we also have to keep the gloves safe. So after we've checked them, we put them on, and we also put on these leather protector gloves over top of them so that we can protect the gloves that we're working with. One other rule that we have to follow when working with these gloves is the one-handed rule, because when you're working with electrical components, you create a path through your body. If you happen to have two hands on a circuit at once, it gives you a path to go through you. So the one-hand rule, as best you can, you try to keep one arm behind you while you're working. This can be difficult when working with leads, but it is very important. So we're going to take a measurement and see how many volts are coming out of this battery before we start. Okay, so this one's a hybrid battery, and this one has a certain number of cells that add up to 270 volts. So out the end here, we should be measuring 270 volts. Give me a second here to set up my meter. When choosing a meter for this task, make sure you pick one that is rated up to 1000 volts DC. And on here, let's read it. It says Category 3 max 1000 volts DC. You must pick this because certain systems are up to 800 volts and the test is actually done at 1000 volts. Something to keep in mind when working with voltages, when it comes to DC voltage, the maximum safe DC voltage you can work with is up to 48 volts. Anything over 48 volts, you must take these precautions. Now I also have high voltage leads here. You're going to see that they have very thin tips on them. Now, the one-handed rule does make this very difficult to work with, so we're going to set this up. Set to voltage. We're going to test the leads themselves, make sure they're working, read 0 volts. Excellent. So the one-handed rule makes this difficult to get these readings. You got to set your meters apart here and try and take this reading with one hand. So I'm going to reach right in here and see if I can get a reading across these terminals. I am actually reading 0 volts across these terminals, so it looks like we may have disabled this already. So it's time to open up the case and see what's inside. So again, one-hand rule, just in case. We've taken most of this apart, but we have a couple of 10 mils left on top here. Take off the 2 retainers. And we still have one 10 mil bolt over there. 2 retainers. Now, some EV batteries, you're gonna have a lot harder time getting into them. Luckily, this is a Hyundai battery and they make it much, much easier to get inside. Okay, so just to take a look at what we're working with here. We got our meter set up. This is the inside of the battery. This one is an air-cooled battery. You're gonna find this in the Nissan Leaf, hybrid products, plug-in hybrids. You're not usually gonna find a liquid cooling inside a plug-in hybrid system. There is the one exception. A Toyota plug-in hybrid, the RAV4 Prime, for example, actually has coolant lines running through them that run Freon. So it has air conditioning Freon running through it with its own dedicated lines. Now, just to show you here, the reason why there is no power at those 2 terminals is because there is a power relay assembly here that is preventing the power to go through. This little module that you see over here is the battery management system. Luckily, this one is very easily serviceable. We get inside, all there is just a rubber seal around the edges to keep it safe from the elements, and we take off the connectors and we can change a BMS. So if we ever have a BMS issue, we can just change this out. There's no worries there. And as we go along here, there is a bus bar behind all these connections, and what you see behind all this orange, which as we know from my earlier videos, orange means don't touch unless you're certified, is there are separate modules. This is much smaller than there is in an electric car because this is just a hybrid battery. If I had to take a guess, this one is probably sitting around 1.8 kilowatt hours, so much smaller than what we're typically used to. What would make this different from an EV battery is that it's air cooled. So the difference between this and an EV battery is there is going to be a plate underneath the EV battery in, say, the Kona or the Ioniq 5 that has liquid running through it to make it a liquid cooled loop. So it's still going to have a similar rebuild process, but you do have to empty the cooling system, drop the battery, you take it apart, and you make it electrically safe before you start replacing modules. Okay, this is one of the more dangerous parts of it because this is a live battery. So I have both of my electrical gloves on, and we are going to take a voltage reading. So for this part of the test here, it's going to be very difficult to follow the one-hand rule. So you have to be very, very careful in what you're doing. What I have separated here, we have the positive side of the battery pack that includes the entire thing, and we have the negative side of the battery pack. And I want to measure the voltage. This is a 270 volt battery. I expect to see around this voltage. So I'm very, very carefully going to take my lead and put it on the negative terminal here, making sure I am not touching anything else and I only have the handle of the lead. And I'm also going to put it here on the positive terminal so I can get a measurement. Now, as you can see on the meter right now, it is exactly 265 volts. So this is a charged battery, probably around the 50% range, because that's how hybrids like to work, is to keep it around 50% if possible. And what we're going to do next is we are going to try and separate this fuse in the middle to separate these 2 blocks of modules, and I'm going to be measuring voltage across the modules to show you how each module works. When you go to rebuild a battery, or if you have a defective cell, what you will be doing is isolating one area. So in each one of these, there are 8 cells per module. And that equals up to 30 volts approximately. I think it's 24 to 33 volts depending on the charge level. So in that range, when I test these sections, I actually don't have to use the high voltage gloves to check those, but because I'm exposed to the rest of the battery, I will continue to keep these on for the rest of the test. One hand rule, and I have a magnetic tip here, so I'm able to grab this bolt, and we get underneath this one here. And this is the other bolt for that fuse. So, working safely. Let's see, we cannot take this fuse out yet. Okay, we have the second nut off of here. Still working with one hand. Now, I have isolated the fuse, the main fuse that will separate the 2 sides of this battery. So that does not still make this safe to work on, it just separates it into 2 lower voltage sections and it breaks up the circuit. So this is going to be what we're going to be doing when we rebuild batteries in the future, is we make it safe, break it down into its smaller parts, And usually you would check for codes before you start doing this because the computer is going to lead you in a certain direction to show you which module is affected. So let's say we went in there and we saw a code for this module right here. So we are going to try and isolate this so that we can break down the battery, pull out that set of modules, and we will replace them. So before we continue, I'm going to take a voltage measurement on the two sections of cells in order to see what the difference is when we separate the circuit into two sections. So we are looking at, I need a stable voltage here, 117.9 in that section. And let's get myself on the negative here and the positive here. And 147.3 volts on this section. So we have lowered it, but it is still in a dangerous range. So you still have to be careful and make sure you keep your gloves on. Working with the one-hand rule, I am uncovering all the sections of the different modules, making sure to keep safe distance from this because this battery is still over 100 volts. Put the screwdriver down, flip this up. Now I have access to all the different modules, so we are able to test this. I'll also open up this side. Okay, I have access to every section of this, so each one of these should be under 30 volts or around 30 volts is what I would expect to see. Stable reading, 29.45 volts. Now, the way a battery management system works is all these cells, modules, and everything have to stay within the same voltage range. And the reason you want them to stay so close is because if one cell or one module was slightly higher or slightly lower, it would actually get used more than the rest of the cells and it would wear out prematurely. And you can't have that across a battery pack. All the cells have to wear at the same rate. If they wear out at different rates, then your battery will fail prematurely. Okay, so we got the first section here. We're going to go to the second one. 29.45 volts. That's exactly what I want to see. I would like to see every one of these sitting at 29.45, and then I know that we have a working BMS. So that's three in a row at 29.45. 29.4546. It's only off by 0.01 of a volt on that one. 29.45 volts, 29.45 volts on this section as well, 29.45 volts, 29.46 volts within 0.01 of a volt, 29.46 volts. So there are only three modules and they're off by 0.01 of a volt, which means that the battery management system is doing its job in this battery and everything is working. So the problem with this battery was very unique. One of the modules, or maybe even two of the modules, had a single cell in them that were not delivering. They would show the voltage, they would charge up, they would do everything they're supposed to do. But as soon as you went to draw a large amount of power through them, one of the cells would drop dramatically. And the computer picked up on this, it noticed the voltage drop from that cell to the rest of the cells, and it said a fault. And unfortunately, we had to remove the battery and change it out. So you would be able to change out that module since it is a fairly new battery, but if it wasn't a fairly new battery, what you would do is you would just match it up with a battery of a similar age, make sure it has the same voltage. So when you go to rebuild these batteries, you actually have to make sure that each module is at exactly the same voltage before you attach the bus bars. Now the bus bars are these things right here where the batteries are connected together. These ones are connected in series, so it goes positive, negative, positive, negative, positive, negative, and so on in one long chain. And the bus bars are what can connect everything together. They are very thick metal in order to carry the amperage required to run a vehicle. What I am going to do now is I am actually going to try and remove the bus bars and get down to the modules at an individual level so that we can take a look at what a battery is built with. Okay, so I have access all the way across here. This is the connection to the power relay assembly. So just like the fuse, this carries the current through the edge of the modules and into the power relay assembly. And the power relay assembly is what allows the power to go to the vehicle. I'll talk about this component in a moment. For now, what I am doing is I am releasing the bus bars from this battery. Before I continue on to those parts, I am going to remove the other part of this. So there is a tab that we flip up, and then there is a secondary lock right here. So we press the lock and we just pull up on the connector to release it. Okay, just use your standard clip tool here to remove this. So now this part is free from the battery. And we've already isolated the two sides, so this cannot carry a current. It's getting safer and safer as we go along inside this battery and remove more components and separate more parts of this. Okay, so I'm going to come up to the camera and show you. These are the small bus bars that connect the modules together. So now all these modules are completely separate. These connectors are low voltage connectors, so you don't actually have to worry about these. Taking the BMS out is very easy to do. Okay, BMS connectors off. Okay, it's just that easy to pull the BMS system out and change it up. Just like before, we are going to take off all the bolts for all these bus bars. Once these bus bars are taken off, I don't need these gloves anymore because it will be completely safe. Take off. And there, we have the bus bars off, and now the battery is completely safe. I do not need high voltage gloves to continue working on this. And that is all the connections. So, take these off now, because every single module is running 30 volts. Everything here is safe and nothing is now connected. So the part that I'm taking off here is actually the cooling assembly. It's fairly straightforward. It's literally just a set of fans and ducts that go over top. So all you do is you take off all the 10 mil bolts, take it out, take off your low voltage connections, take them free. And we got the first cover off. So I'm fairly sure that these are temperature sensors here in order to see the state of the temperature of the battery in 4 different spots in order to control the cooling fans and make sure we stay at an optimal temperature. Okay, so the next part we've removed is the temperature sensor setup. Very simple, perfectly serviceable just like everything else on these cars. Okay, next part to come out, we got the fan. Very easy to change, just a simple squirrel cage. And we've got the duct that goes inside the battery. Again, very simple. It'll be different on an EV. This will obviously have cooling loops, but they'll just be underneath, so you pull the modules off from the top. Now we get into the real fun part. We're actually going to take off all the brackets to hold down the modules of the battery. And I'm going to show you exactly how a battery is going to be rebuilt in the future. Piece of foam to keep it safe in case of an accident on the back side. It's very much the same foam that you find behind the front bumper on a car to absorb the impact. And the second bracket on the back side of it that holds everything down. Okay, now we're getting into the fun stuff. We got the end off here. Got the other end off here. We are now down to the modules. So we have all the spacers that hold everything together. Got more spacers here. These just keep them apart. And we've got this guy in the middle, and this is where the fuse was in order to separate the two banks. And again, it was just another spacer, another way to hold the battery down. We are right down to the separate modules. I'll take a second here to show you some of these connections. These connections right here are all the battery management system connections so that they keep watch on the voltage of every single cell, every single module in order to make sure everything is working. There's also a circuit built in here that will bleed off excess voltage if required in any one section. So this is what we're getting down to. When you go to rebuild a battery in the future, you're going to be able to buy a module like this. This has 8 separate cells inside of it. You can actually see the prismatic cell that is in here, and these are all just 8 stuck together side by side. And that's how we're going to rebuild a battery in the future, just in case you were wondering. So in an EV battery, there's going to be a coolant plate that is right below here. That coolant is going to run through in order to absorb the heat out of the batteries. They might even have fins that go up in between them in order to pull the heat out of them, but this is essentially how a battery rebuild is going to work in the future. So this cell that I'm holding right here, as we measured earlier, is a 30-volt cell. So it's perfectly safe for me to handle because that is below the 48-volt limit. So anytime you take apart a battery, you're going to take out the cells, but you can't just slap them back in here. Unfortunately, there is a piece of equipment we don't have access to yet, and that is a special charger for lithium-ion batteries. Not an expensive tool, but you have to make sure that every single module is charged to exactly the same voltage before you go and put it back together. If you go to put a bus bar across these and there is a difference in voltage, there is nothing stopping it from taking the voltage and the power from one battery and moving it to another. And it will move it at full speed. It'll do it as fast as it can. Those bus bars will get incredibly hot and it's likely you could start a fire. So charge every single module to the same voltage before you put everything back together. And when you reassemble everything, double check, make sure your voltages are correct before you put the bus bars on. Putting the bus bars on is the most important part of rebuilding a battery. Okay, so we can talk about all the components here at once. We have the battery management system, we have the power relay assembly, we have the connections that go to the inverter with its 5-volt reference signal. We have each one of the battery modules here completely separated into its 30-volt sections. We have the wiring that connects the battery management system that goes to each one of these modules to monitor the voltage of the batteries. Also the temperature and everything else, which is right here. We have the small temperature sensors that we use as well, and they monitor the temperature in between the cells. We also have the fan for the cooling system, which as we saw came from over here, and the ducting that runs through it. And as you can see, there are small holes in the tops and bottoms of these so that air can flow between the cells and cool them down. We also have the connections that go to here. We have the main fuse over here. We have the bus bars over here for the different sections, and they just have the little strips of metal inside them in order to carry the current. They're not as big as you'd think they would look. They also look like they're slightly fused, so if anything were to happen, they'd be able to break themselves apart. Now this was an area that was a problem in the original Prius. They were made out of a metal that would actually corrode over time. So one of the repairs that you would often do is you would change out these little bus bar sections in order to save the battery pack. And of course, the last one is the connection from the end of the battery into the power relay assembly. So there you have it. This is what's inside your EV battery. The only thing that's missing from this battery would be your liquid cooling system. Now the car behind me has a completely different battery system inside it. It's using a 2170 cell. They used to use an 18650 cell, which is a little cylinder, and they're set up in a completely different way than these batteries. You're gonna find that most legacy batteries are fairly easily rebuildable because you can get everything apart without too much trouble. Now in a Tesla battery, you're gonna find those cells are separated a certain distance apart to prevent thermal runaway, and the cooling system actually runs around them like a snake. So they're very difficult to get apart. They're also in 4 very large modules, so they run the length of the car, 1, 2, 3, 4. And not only that, they are actually protected with a layer of expanding foam in order to protect them in an accident and keep everything stable. It's quite difficult to keep a battery stable in a car, so you have to come up with different ways to do it. In this one, they just locked it down to some foam bars, and everything seems to be pretty safe. And they also have this special plastic that can break apart in an accident if required. And as we saw earlier, we have our foam over here. And this foam is set up just like the bumper on a car. So the cases on these are designed to take an impact, and they should protect you from any fire risk with these batteries. That brings us to the end of this video. We've learned a couple of things today about rebuilding EV batteries, hybrid batteries, plug-in hybrid batteries in the future. Every manufacturer is going to tackle this a little bit differently. Some are going to be a lot harder than others. Like we said, the Tesla one is actually glued together. It's going to be a lot harder to get those cells out. But anyone that uses a prismatic cell like this is going to be much easier to take apart, especially when the cooling plates are below it. These will bolt out and bolt in very easily. So just for example, this is a very, very small pouch cell, not the size that are in here, but that is one version that they use. Another one that they use is the little cylinder cells that you find in the Tesla models. So if you found this video helpful, please like and subscribe. It really helps us out, and thank you for watching.